Okay, to do this week 15 video, what we are going to do is open Desmos, and we're going to open Desmos, the graphing calculator. So if you come over, let me go back to this screen here. If I go back, I want to do Desmos. See, normally we do scientific calculator, but just hit desmos.com and it'll come up with this graphing calculator right here. And that's what we want to deal with. We want to do with the graphing calculator. And one of the things we want to focus on, if you look at question number 1, is how can I change this graph x squared? So x squared, is just a U-shaped thing. It hits at 0, 0, 1, 1, 2, 4, 3, 9. I don't have a very pretty graph, but I can actually go back to Desmos, and you can see there's my graph right there. So open up Desmos right now and set this up so that you can have x squared on your graph, and we'll keep going from there, because what we want to do is, if you look at question A, it says, how can we make the graph stretch vertically? That is, how do we make the graph look narrower? So we're going to put in some numbers, okay? I'm gonna take this graph right here, and I'm just going to put a number in it. I'm going to put the number 3. It got narrower. How about if I put 25? Oh, it got really skinny. How about if I put the number, well, 1's not going to do anything because that's 1 to 1. What if I make it a fraction? 1/2, 1/10. Ooh, it gets fatter when it with a fraction. So that's interesting. Here's our x squared. Here's, in blue, is 4x squared. And in orange, there's like a 10x squared. So the bigger the number gets, the more that stretches, like it stretches up towards the top or gets bigger vertically. It gets skinnier. And then if with a fraction, the fraction, like 1/4 that I did in green, I'll take off this orange one, so we just have 3 to look at. We have our original one in red, x squared. To get it to vertically stretch or get narrower, we put in a number, a whole number. And to get it to what's called compress or get shorter, fatter, think about when you have like clay, if you're in art, and you squish it down, it gets fatter, right? Or compresses. So it's kind of weird. To get skinnier, you need a big number, a whole number. And to get fatter or wider, you need a fraction. So let me go back to our little graph right here. So what is it that we need to do to get narrower? To get narrower, you need to put in a whole number in front of x squared. And if we want to, let's see, compress vertically, we put in a fraction. Oh, you can't see the yellow. I'll change that color for you. To compress it vertically, you put in a fraction in front of x squared. All right? And so now we know how to either make it skinnier or to make it fatter. Like fatter. Can you see the yellow on the graph? Yes. Okay. So I'm kind of color coordinating. Narrower is in the orange, and compress or fatter it's in yellow. All right. Now, how can I change the equation to open downward? We'd actually talked about this in an earlier week. To make the graph open downward, what do you think we have to do? Let's go back to our graph. And to make it open downward, let's just focus on x squared here. To open downward, okay, I've already tried some numbers. We know that doesn't work, but what if I put a negative? If we put a negative, then we know it's going to open downwards. So, and again, what if I did negative, if we come over here and make this -4, oh, and we need to see that graph. -4. Notice the whole number 4 is still thinner, but it's opening downwards. And if I go here to 1/4, that was the compression. The compression with a fraction, it's still a wider graph. It's just that it's opening downwards. So that negative number is what's going to make it open downwards. So let's go to our paper and write that down. Okay, how can I change the graph of the parabola so it opens down? Okay, put a negative in front of x squared. Okay, now let's look at this one. Let's start with our graph again of x squared. Okay, our graph x squared, I'm going to kind of estimate it out like this. That's our original. And how do we shift the parabola 5 units down? How do we shift the parabola 5 units down? Well, let's go back and play with Desmos and let's see what's happening here. We're going to go to a positive x squared, and I want to shift it 5 units down. So it's going to, the vertex is going to move down here. So what if I subtract 5? Let's pick this graph right here. X squared minus 5, see how it subtracted 5? What happens if I change that to an add 5? Oh, it shifts it up. Okay, and then so it shifts it up or down depending on whether you want it to shift up or down. So that's nice. The positive is positive, the negative is negative. So we'll go back to our piece of paper and write some notes on that. To shift 5 units down, 1, 2, 3, 4, 5 right here, to shift 5 units down. Our graph looks exactly the same except for the parabola is just shifted down. Okay. So you're just going to subtract 5 from x squared. So you get y equals x squared minus 5. And then how do we move stuff left and right? How do we move stuff left and right? So let's see, to go left and right, let's go back to our parabola or to our Desmos and see what's going on here. We want to now move it left and right. We don't want to go up and down anymore. We want to go left and right. So what happens if I put a number inside the set of parentheses? I have x plus 3, and you see how x plus 3 moves it to the left? Well, that's weird. Plus 3 seems like it should go to the right, because positive is always moved to the right. But this moved it to the left. So what's going to happen if I change this plus to a minus? Oh, it went the opposite. Okay? So that's just very interesting to note. I know that when I teach this in person, I talk about how you mess with the x. See how over here, this x squared, I put the 3 inside, and it does the opposite of what I think it would do, because this says x minus 3, and it went to the right. If I change it to a plus 3, it goes to the left. So it's messing with you, just like your ex-boyfriend or ex-girlfriend, you would mess with them, haha. And so you do the opposite of the x. But then this minus 5 here does what you want it to do, whatever's on the outside. So let's say, let me copy this and make another graph here. Blue, okay, the blue is the same, yeah, as the black, okay. What if I did x minus 5? So now look at, I shifted it, this is a positive 3, and here's my original in red. I went 3 to the left and then 5 down. So I had a combination of those graphs. Now what would happen if I put a number in front of that? If I made it a 4, remember it stretches vertically. What if I made it a negative 4? What do you think is going to happen? Oh, it's going to stretch. The vertex still moved 3 to the left of the opposite, because this is a positive, so opposite, but then the outside number stays negative, and then I went -4 instead of +4 because I made it a negative. Now it's a positive again, and it's opening up. I'm going to get rid of the 4, and now I have my original parabola, the same exact shape and size, but I just moved it 3 to the left because this says +3, and even though left is negative, you mess with the x and we go the opposite, and then down 5. Let's go take some notes on our piece of paper, and let's see what we have. So how can I shift the parabola 3 units to the right? 3 units to the right, x3 squared, and to the right is going in the positive direction, so we do the negative. And let me draw that picture here. Shift 3 units to the right is 1, 2, 3, and that's this one right here. Keep this color coded for you. X minus 3. So you use the opposite of the number to go left or right. I hope that makes sense. You do the opposite. And now look at this one. How can I change to the equation f of x equals x squared? We want to do 3 units to the left. So we know to the left is this way. So we're going to go x3. And I want to go to the left, 1, 2, 3, that's the negative direction, but I use the opposite when I'm inside, and it's going to be squared. And I want to stretch vertically. Remember my stretch, I want to make it look narrow, I have to put a number in front, as in part A. And we can try that. Let's go to our graph, x plus 3 squared. We did try it, but it's good to see it again. Over here. So we did x plus 3, and then if I put a 4 in front, let me take this graph off. Now you see what I did is I moved it 3 units to the left, and then I stretched it, it got skinnier. All right, let's go back to the next page. Go to our paper, and I turn to the page, so now I'm on page 14. Explain how the different constants affect the transformation. Okay, so let's see. A is going to either, see, this is the number outside, it's either going to stretch or compress. Stretch is going to be a whole number, and compress is going to be a fraction. Okay, H, you use the opposite to move left or right. And then the value K, you're going to use to transform or move up or down. Okay. So there are some practice problems here. So when you do these, I want you to have Desmos out and actually using them. How can I change this equation to make it vertically compressed? So compressed, I can see I have to use a fraction. Let me spell fraction correctly. How can I open it downward? Okay, remember downward is positive or negative. I have to shift it 6 units up and shift 2 units to the right. So you have the notes right here of how you're going to make that equation. And I want you to practice on Desmos, and when you get it right, put your answer in here. And same thing with problem number 2. Use Desmos to set up these scenarios right here that are provided for you, and then once you get it right, put the answer. It's going to be good practice. All right, have a great day.